So good morning everyone. Am I audible? Anyone just reply?
Yes, sir.
So good morning everyone. Am I audible? Anyone?
Yes, sir.
Okay then. Is, is the screen visible to you all? Everyone?
Yes, sir.
So if anyone have any problem with audio or with the screen that I share, just reply no. If you have any problem. So I assume that everyone is okay with the audio and the slide. So good morning once again. So today I'm not going to take any new topic. So we are going to just discuss what I have been sending in the Google Classroom. Okay. So the first thing is I have shared you the syllabus where it includes the reference book. So you can refer the book by this Alfred B. Eho, which we also call it as a Dragon book. So the title is Compilers, Principle, Technique and Tools. Yeah. Okay, just a second. Lloyd, yeah, Benito. So the first thing is what is a language processor? So we know that a language processor is nothing but a program that converts a source program to another program. So when we're talking about this compiler, we can define a compiler as a program that converts one program which is in one language and translate it into another equivalent program which we call it as target language. Or we can say that a compiler is a program that converts a high machine level language. Okay, so the important role of a compiler is to translate the program from one language to another, and it has to report any errors in the process of converting from the source program to the target program. Okay, so if we see how compiler look like, so compiler, here you will have your source program that will be in high level language, and your compiler will convert it into a low level language or machine language. So in the process, if there is any error, so your compiler will give you the information about the error. Okay, so this is your compiler. So it converts your source program to target program. And if your target program is a executable machine language program, then we can process it with the input and produce the output. Uh, so there are a few other tools that may be related with a compiler. So the first one is what we call it as interpreter, and the another one is assembler. So when we talk about interpreter, so it's slightly different with compiler, as here your interpreter will directly execute the operation specified in the source program on the input supplied by the users. So when we are talking about compiler, we are going to process all the programs at once. Okay, so your interpreter and the compiler, the working process is same, and the ultimate output will be same, whereas your compiler will process all the program at once, and your interpreter will process it line by line. Okay, so it will process line by line. If there is any error at one point of time, then it will inform the error, and once we rectify the error, then it will go to the next line. But when we're talking about compiler, so it will just process the whole program, and once it's done, it will give the error information. Then we have another, that is assembler. Okay. So when we're talking about assembler, okay, so we're going to convert assembly language to machine language. Okay, so when we're talking about interpreter or when we're talking about compiler, we convert the high level language to machine language. Okay, so compiler or interpreter, we're converting high level language to machine level language. And when we're talking about assembler, we're converting assembly language to machine language. Okay. Okay, and so this is the structure of a language processing system. So it will have your preprocessor, then it may have your compiler, then your assembler, then your linker and or loader. So your source program will be first has to go through this preprocessor tool, where it will give you a modified source code, and once you have this modified source code, it will be converted to the target assembly program, and your assembler will convert it into again to the relocatable machine code, and your linker and loader is going to link and load all the files together to the secondary storage for execution. So like, why do we need linker is all your executable file may be in different pieces in different locations, so everything has to be bring out together. So for that purpose, we use this linker and loader. So coming to the main part, that is we are going to discuss today, that is structure of a compiler. So when we are talking about structure of a compiler, we have like two parts. First, we call it as analysis, and another one we call it as synthesis. So these two parts divide the whole conversion into so so your analysis part is going to break up the source program into different pieces, and it's going to check for its grammatical structure, and if any error is there, then it has to rectify in every stage of the execution. So here in this analysis phase, so it will give an intermediate representation of our source program. So here your grammatical structure will be set, your synthetical uh, error will be checked. So if everything is okay, it will be passed to the next part, that is synthesis part, where it will give you the machine language code from the intermediate code. So, and either it may be analysis part or synthesis part, we're going to use a data structure called as symbol table. So all this information has to be stored in this means all various information will be stored and used by this symbol table. So So the synthesis part construct the desired target program for the intermediate representation and the information in the symbol table. So all the information that we store in the analysis part uh, in the symbol table will be used by the synthesis part to get the desired target program. So we we also call this analysis part as the front end of the compiler and the synthesis part as the back end of the compiler. Okay, so this is the structure of compiler when we divide it into parts, and this part again can be we can classify it into phases also. Okay, so we have different phases for this compiler. So let's see all those different phases. So here we have the definition for symbol table. So the symbol table, so it's a data structure which is going to store information about the entire source code, and it's used by all phases of the compiler. So here is the phases of the compiler. So the first phases is lexical analyzer. So this is your first phase. So the first phase is lexical analyzer, then second is syntax analyzer, third is semantic analyzer, then fourth is intermediate code generation, then you have uh, code optimization, then you have code generation. So these are the different phases of the compiler. So whatever the program that we give, it's nothing but is a form of character stream. Okay, so all those character stream has to be go through the first phase, that is lexical analyzer. So it will convert all those character stream in the form of tokens. Okay, so so once you have this token streams, it has to go with the syntax analyzer to check, and it will give the syntax tree, and it will check for any syntax error. And once it is done, then it will go to the semantic analyzer, and you will check for the grammatical structure of the program. Once it is done, then it has to go through the next phase, that is it will go through this intermediate code generation to give you an intermediate representation of the program. Then once we have this intermediate representation, so this different phases till intermediate code representation may belongs to the analysis part. Okay, and the remaining is your phases that belongs to synthesis part. So once you have this intermediate code generation, then you have to do code optimization. So wherever you can remove that number, means instead of writing 2 lines of code, if you can write it in 1 line of code, then all those optimization has to be done. So once we have done that one, then we can go for this code generation, where it will give you our code in the form of our target machine code. Okay, so these are the phases of a compiler. So in all those process, we are going to use the symbol table, and we are going to report all the phases of the compiler if there is any error. Lexical analyzer again. Let's see. This is a brief discussion on this lexical analyzer. So the first phase, as I have mentioned, is called as lexical analyzer or analysis or scanning. Okay, it's called scanning because we're going to scan the character stream of our input, and we are going to give the output as tokens. So the function of or the role of our lexical analysis is nothing but to read our input character stream of the source program, and then we are going to group the characters into a meaningful sequence called as lexemes. Okay, and this lexeme is going to this lexical analyzer is going to produce the output as in the form of a token. Okay, so your token form will be of this. So it will have your token name and it will have your attribute value. So attribute value, we're going to just some number over it. So, and then token name is whether it's some identifier or it is some operations or some. So in this token, so your token name is an abstract symbol that is used during syntax analysis, and the second attribute value points to the entry in the symbol table for this token. So all this information about the token is going to be stored in the symbol table. So this attribute number is going to give the position of this information in the symbol table. Okay. So let's see this example, then you'll understand it. One. So here we are given a line of code. Okay, so this line of code is a part of the program. So here let's see how this line of code will work with the first phase, that is lexical analyzer. So here we have the stride position equal to initial plus red into 60, or you may have any line of code like a equal to b plus c. So in that form, how this lexical analyzer is going to do is first, its role is to scan this given line of code. So here your lexical analyzer is going to start scanning from left to right. So it has to start scanning from left to right, and until it finds any space. So when you have a space, it identifies that that is an item, and we have to identify it. So when we have this position, so when we show position, it is nothing but an identifier. right? Position is an identifier, equal to is a symbol, initial is also an identifier, plus is an operation, then red is also some identifier, then star is an operation, then 60 is just a constant number. Okay, so if we look over here, or if you say like in A, B, and C, so we have initialized an integer value A, B, C. So that ABC is nothing but a part of identifier, right? So similarly, this here also, when you have this line of code, lexical analyzer is going to uh, scan this one and find its corresponding tokens. So when we have this line of code that is position equal to initial plus red into 60, so it will start scanning, and once you have at the end of n, you understand that that is a item, so or entity, so which is being corresponds to something, so it is nothing but a identifier. So your position is an lexeme that would map to the token. This is our token. We tell that it must have some token name. So since the given position is nothing but an identifier, we use the short form of identifier, that is id, then comma, then attributes value. So we give the value as 1. So we'll store it at one position of the symbol table. Okay. So here it has been mentioned that id is an abstract symbol standing for identifier, and 1 points to the symbol table entry for position. So the symbol table entry for an identifier hold information about the identifier, such as name and type. Okay. So like we are going to store in this location 1 of the symbol table, and we have given the information that this given position is nothing but an identifier. Okay. So once we have done that one, so the next that we got is equal to. So equal to is nothing but a assignment symbol. Okay. So we're going to map it in the form of just token here, because here we don't need any attributes value. We cannot give any other information other than that it is just an assignment symbol. So this is our representation in the form of tokens for this second thing, that is assignment symbol. Then once we are done with this, then we have to go to the next one, that is initial. So initial also same thing, it is an identifier, and we will give the token that is identifier, and we are going to place it in the symbol table place number 2. Okay, so this is for the identifier. And if you go for the next one, addition or plus, so here it is. So this is our token that is generated. This, and red also same thing, red is also an identifier, so we're going to store it over here. Okay, then we have star or multiplication, so we're going to generate this token. So similarly with 60 also, 60 is also a constant number. We cannot do anything other than information that it is just a constant. So we're going to just give the token in this form. So this is our representation. Okay, so this is our representation for that particular line of code. This particular line of code, that is position. That is position. So this position equal to initial plus spread into 60. So this is our initial source code. And once we have gone through it with the lexical analyzer, it's going to give the token, and this is our result from there. So the first one form is identifier, then we have assignment, then we have another identifier, then we have addition, then we have another identifier, then we have multiplication, then we have a constant number that is 60. Okay, so this is our token representation of the initial line of code. Okay, so if here if we see this diagram, then you will see the overall. Okay. Is it visible to everyone?
Yes, sir.
Okay, or shall I increase the size? Okay, let me. So here is an overview. You will understand it with this. So as I have mentioned before, here is our initial line of code. That is initial line of code. Then once we have gone through with this lexical analyzer, it's going to convert it into tokens. So this is our tokens for the first portion, then similarly for this one. So if we have this one, we have this as tokens. And if we have say a plus a equal to b plus c, then we are going to have without this part, that is we won't have this into 60. So considering another line of code that a equal to b plus c, then everything will be similar till here. Okay. So once we have these tokens, so next is we have to form the syntax tree for that one. So this is, we are just drawing the syntax tree for this one. Once we have the syntax tree, then we have to check for their semantic correctness. So here, when we assume that all these identifiers has been declared in the form of a float, so we assume that it has been declared in the form of float, then your constant is not in the form of a float. So we need to convert this given integer or the constant in the form of a float so that it can work out with the other identifier present in the line of code. So there comes the correctness of this, their semantic. So we correct this 60 to convert it into float so that it can work out with this. Okay. So once we have this semantic analysis, then we have to go with this intermediate code generation. So here we have different type of representation of code generation. We have tree address code, we have some tuples, then we are going to see once we come to this intermediate code generation. Means here every phases we are going to study as a chapter in the later classes. So for now, we're just showing an overview of what the different phases is going to do. So here it gives some intermediate representation. So here we have some new 3 temporary variables, say t1, which is going to store the float of your number. Then once you have t1, then we are going to do multiplication with the identifier number 3. Once we have done that one, then we are going to do the addition with the identifier number 2. Then we are going to give the result to the identifier number 1. Okay, so this is our one form of our intermediate code generation. So once you have this intermediate code generation, the next task is we have to some code optimization. So if you see over here, we have represented the intermediate code representation in the form of 4 lines of code. So in code optimization, we see whether we can reduce lines of code so that we can save space and time. So here, instead of this 4 line, that 4 line can be replaced by this 2 line of code, right? So T1 here, it carried in temporary T1, it carried out the role of this multiplication of identifier tree with a float form of 60 dot 0. Okay, then once we have that T1, we just do the addition with the identifier 2 and we just place it, assign it to identifier 1. So in this form, we can just optimize our intermediate code by this code optimization. So in code generation, we know that our main aim is to convert our high level language to the machine level language, right? So converting this lines of code in the machine level language. So here we are just loading. So this is load float. I think you must have studied this in detailed design of this thing. Load, then multiplication, load, addition, store. We include F because we are dealing with float type of information. So load F for float. So we are loading, multiplication, loading again, we are doing adding, then we are just storing. So this is our representation of our machine level code of the previous given original line of code, that is this initial equal to position equal to initial plus red into 60. Okay, so this is our overview of our compiler. So your symbol table, as you see here, is going to store information about the different identifier that is in the line of code. So here we have position, initial red, and any other information may be included over here. So here it is just a explanation of what it goes out with syntax analysis, then in semantic analysis, in intermediate code generation, then code optimization, then we have code generation. Okay. So here we are just giving you an overview of the compiler's phases. Then even you have symbol table management. I have even given you Google Classroom that what symbol table role is in different phases of the compiler. Okay. I think that's it for today, and if you have any doubt, you can tell me. And shall we have live classes daily, or shall we have 1 or twice per week?
1 or twice would be better.
Okay. And anyone, are you following what I sent in the Google Classroom? Whether are you following it or not? Any changes you want me to make?
I think it will be fine as it is.
Okay. I don't know, everyone is presenting or just you're keeping it login and you're just gone. So, okay, let me show you. So is roll number 1 in the group?
Yes, sir. Present, sir.
Okay. Just a second.